Hi y'all, this is a video about section 3.1 where we get to practice identifying points in the XY plane, and we're also going to use the distance formula and midpoint formula to find distances and midpoints. So let's remember that the distance d of P1, P2 is how that's read out loud. The distance between any two points P1 and P2 in a coordinate plane is given by the square root of their x coordinates squared plus the difference in their y coordinates squared. That's related to the Pythagorean theorem. The midpoint of the line segment between 2 points, or the midpoint between those 2 points, is given by the average of their coordinates. So the the x coordinate of the midpoint is the average of the x coordinates, and the average of the y coordinates of these 2 points gives the y coordinate of the midpoint. So let's use those formulas to do some problems here. We have several points A, B, and C, and we want to find distances and midpoints between some pairs of points. So let's go ahead and do that. Before we are able to use the formulas, we have to identify the coordinates here. So the point A has coordinates, the x coordinate is -2 and the y coordinate is 4. So it has coordinates -2, 4. And the point B has x coordinate 5 and y coordinate 3. So its coordinates are 5, 3. The distance, let's recall our distance formula, will be the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's identify, I guess if we call A the first point, it has coordinates x1, y1, and B has coordinates x2, y2. So now we have some values corresponding to these variables. For x2 minus x1, we have 5 minus a -2 squared. For y2 minus y1, we have 3 minus 4 squared. 5 minus a -2 is 5 plus 2 is 7, and 3 minus 4 is -1. And so this is the square root of 49 plus 1, which is the square root of 50, which actually reduces. Let's make sure that we're reducing all of our square roots. 50 is 25 times 2, and 25 is a perfect square. So this is 5 square root 2 is the exact distance between those 2 points. So that would be part A. Part B, we're meant to find the midpoint. Remember, our midpoint formula is we take the average of the x coordinates, x1 plus x2 divided by 2. That's the x coordinate of our midpoint, and the y coordinate of our midpoint is the average of the y coordinates of the 2 points, y1 plus y2 divided by 2. So now we plug and chug. We have x1 plus x2 is -2 plus 5 divided by 2. y1 plus y2, 4 plus 3 divided by 2. And that gives us a final answer of -3/2 is the x coordinate. Sorry, +3/2 is the x coordinate. -2 plus 5 is a +3. And the y coordinate will be 7/2. So if we go out and find this point, 3/2 is 1.5. And 7/2 is 3.5. And so our point will be right about there. We connect. That's a crappy straight line, but there is our midpoint right there. All right, let's move on to the next problem. We want to find first off the distance between points C and D. First off, we need to identify some coordinates for points C and D. Point C has x coordinate 1 and y coordinate negative 5, and point D has x coordinate negative 3 and y coordinate negative 2. So using our distance formula, the distance between C and D will be the square root of, take the difference in their x coordinates, so negative 3 minus 1 squared. We need the difference in the y coordinates squared as well, so negative 2 minus a negative 5. Squared. Negative 3 minus 1 is negative 4. Negative 2 minus a negative 5 is negative 2 plus 5, which is 3. So we get the square root of 16 plus 9, which is the square root of 25, which is 5. So this distance is a nice number. By the way, I guess the way that this relates to the Pythagorean theorem is if we draw this right triangle, this side has length 3 and this side has length 4, and it is a right triangle. And you may have remembered there is a 3, 4, 5 right triangle, so the hypotenuse has length 5. That's the distance between those 2 points. In part B, we want to find the midpoint, and that is, well, the x-coordinate of the midpoint is given by the average of the x-coordinates of the points. So let's add the 2 coordinates and divide by 2. That gives us the average of those 2 points. Same thing for the y-coordinate. We want to find the average of the y-coordinates. And when we work out the computations, we get negative 2 over 2 and negative 7 over 2, which gives us a midpoint of negative 1, negative 7 halves. Which looks to be this point right down here. Last one here, we have, let's see, the points D and A. So let's remember that A has coordinates, or sorry, D has coordinates negative 3, negative 2, and A has coordinates negative 2, 4. So for part A, the distance between those 2 points. Now it doesn't matter which one we call point 1 and which one we call point 2, but let's just go ahead and stick with the problem statement and call D point 1 and A point 2. We have x2 minus x1, which is negative 2 minus a negative 3 quantity squared. Then y2 minus y1, 4 minus a negative 2 squared. And then we just got some number crunching to do. Negative 2 minus negative 3 is a positive 1. 4 minus a negative 2 is a positive 6. And this works out to be the square root of 37. So sometimes our distances work out to be nice numbers, like in the second one, where the distance was 5. Sometimes they result in square roots that can be reduced, but not completely, like we had in number 1. And sometimes they work out to be square roots that can't be reduced. But you always want to simplify any of these square roots as much as you can. The midpoint is given by negative 3 plus negative 2 divided by 2. That's the x-coordinate. The y-coordinate is negative 2 plus 4 divided by 2. And that gives us, it looks like negative 5 halves, 1 when we simplify things. All right, so there's our problems involving the distance and midpoint formula, at least the straightforward ones. One last problem here in this set. I want to find all points on the x-axis that are a distance 5 away from the point negative 2, 4. So let's try to get a visual of what's going on here. We have the point negative 2, 4. It's our point P here. And then we want to go 5 away. Now if I go 5 straight down, I get to this point down here. And there are a lot of points that are 5 away. If I move just a little bit to the left, I can get to this point. A little bit to the right, I get to this point. And there's lots and lots of points that are 5 away. I guess the point here is that there's actually a circle with radius 5, that it looks like it cuts into, that's with P at the center, and it looks like it cuts into the x-axis at 2 places. All right, so we're going to have 2 points. We're going to have a point x1, y1, and a point x2, y2. Now notice that both of these points are on the x-axis. So y1 and y2 are both 0. The y-coordinates of both of those points are 0. Actually, any point on the x-axis, the y-coordinate is going to be 0 for any point on the x-axis. So that gives us some clues about how we're going to do this. Now we want the distance between our point. We're just going to call our point xy. Let's give it a name, Q. QXY. And actually, QXY is going to be QX0 because all of our points that are on the x-axis, the y-coordinate is going to be 0. And we want the distance between our point Q and the point P to be 5 on the one hand. All right, we want that distance to be 5. On the other hand, we can actually write down a formula for this distance. The distance between our point Q and the given point P will be the square root of x minus a negative 2 squared plus y minus 4 squared. And since we know the value of y, we can simplify some things here. We get x plus 2 quantity squared plus 0 minus 4 squared. So we have an expression in a variable x, and we know that that expression has to equal 5. The square root of x plus 2 squared plus, I'm going to go ahead and simplify that to 16, has to be 5. All right, let's go ahead and solve this. Now, for reasons that are going to be obvious in just a second, I'm not going to simplify the stuff inside the square root any further. All right, we're solving a square root equation. And so let's square both sides. If we square both sides, we get x plus 2 squared plus 16 is equal to 25. And then here's why I didn't simplify the stuff under the square root. If now I can just subtract 16 from both sides, and I kind of have one of these nice special quadratics. 25 minus 16 is 9. So I can take the square root of both sides. X plus 2 is equal to plus or minus square root of 9, which is plus or minus 3. And so x will be 2 plus or minus 3. Sorry, negative 2 when I subtract 2 from both sides. Negative 2 plus or minus 3. So I get, all right, my point x1, or at least the x-coordinate, is negative 2 minus 3, which is negative 5. So it looks like my picture was just a little bit off. And the second x-coordinate, the coordinate of this second point out here, will be negative 2 plus 3, which is 1. Now, we're not quite done. They want us to find all points, not the x-coordinates of the points. They want us to find the points. So let's go ahead and identify that our first point has x coordinate -5 and y coordinate 0. So that's one of those 2 points. And the second point has x coordinate 1 and y coordinate 0. So those are our 2 points. All right, I hope this video has been helpful. If you have any questions, please send me a message on IvyLearn or via email. Thank you.